So again, this is the second video where we talk about how figures are usually drawn to scale, and you can essentially make a guesstimate and get a lot of these questions right. All right, number 35. And again, I've included part of the diagram and part of the question, but I've left a lot of it out because ultimately this is what they want to know. They want to know what is the length from point A to point C. I'll do my best to draw a straight line. So we can see that's the hypotenuse of this right triangle. And you may just know this answer, but we know this is obviously going to be longer than 5. So we know it's not this answer. 25 seems ridiculous. If this figure is indeed drawn to scale, that number seems ridiculous, and so does 20. So really it comes down to, is it choice A or choice B? And we need the decimal version of those numbers to figure that out. So 2 times the square root of 5. Type that in the calculator. We get 4.4. We know that's not the right answer. So the answer has to be 5 square root of 2, but let's put it in the calculator just to be sure. And that makes more sense. 7 seems about right because it's just a little bit bigger than the side that we already know. So C is the answer. Number 6, where do these graphs intersect? Now, using a straight edge would be the way to do this ultimately. These days, I know the ACT a lot of times is on the computer, so it makes it a little bit tougher. But still, you could kind of use your pencil. If you had 2 pencils, you kind of line them up, see where they intersect. Mine intersect roughly at this point here, which looks to be at 1, 4. And that is a choice. I know it's not this one. Negative 1, 5 is over here. 2, 5 is way up here. That doesn't seem likely either. 4, 1 is down here. There's no way it's 4, 1. So it's either G or H, and I think G is a pretty good guesstimate there. 13, what is the length from point A to point C? We know this length from A to E is 12. So if that's 12, we can kind of make a guesstimate on how long E to G is and how long G to C is. To me, E to G looks a little bit less than 12, and G to C looks a lot less than 12. So if we did something just a little bit less than 12, and then a lot less than 12, add those together, that gives us 28. 12 plus 10 plus 6 is 28. So a couple things we can do with that. We know it's not 9. We know it's not 18. It's a little bit tougher. Let's look at the other side. This length over here is 15. So that length in red is 15. What do we think about this full length then? Is it bigger than 15 or smaller than 15? Obviously it's bigger. The question is, how much bigger? 36 seems like it's probably too much. So I've at least narrowed it down to C and D. Make your best guess on 13. And then finally 32, what is the length from A to C? So we're trying to find this side, which is not the hypotenuse. So we don't know that it's bigger than 12, but they look similar to me. They look like they're about the same length, roughly. We know it's not 2. We know it's not 4. 20 doesn't make sense either. That's way too big. 16, maybe. But I would be interested in 4 radical 7. If we type in 4 times the square root of 7 in the calculator, that answer is 10.58. That answer seems maybe a little bit better because we do think this length in green is pretty close to 12. And 10.58 is closer to 12 than 16 is. But make your best guess. And then let's real quickly, let's go over a couple of the questions. We don't need to go over 35 or number 6. We felt pretty confident about those, but 13 and 32. Let's look at those 2 questions. And you'll notice now on 13, they give us a little bit more information in this problem than we had previously. They give us the length of each individual side. This is really helpful. I'm not going to lie. If this length is 6 and this length is 12, well, that just means we're doubling each one of these smaller lengths to get 10 and to get 8. So 12 plus 10 plus 8, that gives us 30 altogether. That's one where cutting out some of the information wasn't helpful. And then finally 32, the right triangle shown below, the length of BC is 12, and the sine of A, angle A, is 3/4. So if you remember the formula for sine, the sine of an angle is equal to the opposite side divided by the hypotenuse. It's just the ratio of those two sides. Well, the opposite side of angle A is 12. The hypotenuse is unknown. We don't know that just yet, but we know that this exists in a ratio of 3/4. So to solve for x, we can cross multiply. So that gives us 3x. Cross multiply here. That equals 48. Divide both sides by 3. And x equals 16. And now we can do Pythagorean theorem to find the missing side. A squared plus b squared equals c squared. So A we'll call 12, B is our unknown, and C is 16. 16 squared is 256. 12 squared you should know, but if you don't, no shame in putting the calculator. It's 144. Subtract 144 from both sides. And we get b squared equals 112. Last step is take the square root of 112 to figure out what b is. I think it's pretty safe to say it's 10.58. That's equivalent. We found that earlier. That's equivalent to h4 radical 7. So making a guess on that problem, chances are most of you guessed h, and you avoided having to do all this work, which is going to take you a couple of minutes. So the guessing strategy is good to use when you don't know for sure, but also sometimes just to save a little bit of time on a problem where it's obvious what the answer is when you make that guesstimate.